Trigonometry Made Simple by Anil Kumar. I am Anil Kumar. Welcome to my series on trigonometry. We'll calculate exact value of tan 11 pi by 12 in radians, or if you write it in degrees, it will be, as you know, tan of 165 degrees. Let me thank all the viewers and subscribers watching my videos and for their request on some videos on trigonometric functions, including this one. In case you want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. Now, to answer this question, we'll first look into things which we should be ready with. So, we are going to use compound angle formula, which is tan A plus B formula. Right? So, let me rewrite the formula here for convenience of those who do not remember. So, it is tan A plus tan B over 1 minus tan A tan B. Now, if we are looking for tan A minus B, then the sign changes, right? That is the change for tan of A minus B. That's one part. Now, how do we split 11 pi by 12 into A and B? That is a major question. Now here, I will use a strategy, and the strategy is to write a related acute angle. So, we'll also look into related acute angle. As you know, trigonometric functions repeat, and therefore what we can do is we can find the related acute angle and then solve it further. Now, let's visualize what is tan 11 pi by 12 and where it lies. 11 pi by 12 means this is 12 pi by 12, correct? This is 0. Working in radians is actually not that difficult. For some students, it is new concept, so it may be slightly challenging at present, but it's very simple. See, 12 pi by 12, when I say 11 pi by 12, then we're talking about this principal angle, which is 11 pi by 12, right? So as you can see here, that the related acute angle is only how much? Pi by 12, right? So this is pi by 12. So that is one thing. So that means if I look in quadrant 1, that will be pi by 12, right? Second, we have to consider the cast rule, right? So we know in quadrant 4, or cosine is positive, all in 1, sine in quadrant 2, and tan in 3. So we know this value is going to be negative. So let me rewrite the question here. Tan 11 pi by 12 can be written as minus, since you are in quadrant 2, and the related acute angle being pi by 12. So it is minus tan pi by 12. Makes sense? You get the idea. So that is the first step. If you are working in degrees, then in that case, you will write this as tan of, rather minus tan of 15 degrees, correct? 180 minus 165 will give you 15 degrees. Okay, great. So you can work in either. I know working in degrees is simpler, so I will do it in radians. So now, once we have this, how do I write pi by 12 as a combination of A and B using special triangles, right? Special triangles, where I say I really mean it is pi by 3, pi by 6, pi by 2 triangle or pi by 4 triangle, correct? So very easy. Tan of, we want just pi on the top, means 4 minus 3 will give me the result, right? So we can write this as 4 pi by 12 minus 3 pi by 12. Makes sense? So we could do this, right? So that is one way. 4 minus 3 is 1, right? So that could work fairly well for us. Now that is equivalent to tan of 4 pi by 12 means pi by 3 minus pi by 4. Pi by 3 minus pi by 4, or you can write in degrees, 60 minus 45, right? And then continue, right? So I think so far major step was write it in related acute angle, because this angle could be a coterminal angle, a very big angle also. So make it a standard practice. And once you have a related acute angle, it is easier to work with numbers, right? So we know it's in quadrant 2 and therefore tan will be negative. So let's get back to the question. So we so far have realized that tan 11 pi by 12 can be written as minus tan pi by 12, that is the related acute angle, which is minus tan pi by 3, 60 degrees, minus pi by 4, which is 45 degrees. Now we are going to apply the formula, right? So it is tan, so it is negative here. So let me write down negative first. Tan A minus tan B. So tan of pi by 3 minus tan of pi by 4 over 1 plus tan A tan B times tan pi by 4. Is that clear to you? So that is the formula. Now exact values of tan pi by 3, pi by 4, you can use the special triangles. So we are using these two special triangles. So pi by 4 or 45 degrees, we know 1, 1, square root 2, and here it is 1, 2, square root 3, right? Pi by 3 is this angle, pi by 3. Correct. So let's substitute these values now. So we get equal to minus tan pi by 3 will be square root 3 over 1. So I could write this as square root 3. Minus tan pi by 4 is 1 over 1 plus tan pi by 3 is square root 3 times 1. Correct? So we get minus square root 3 minus 1 over, square root 3 minus 1 over 1 plus, you can also write square root 3 plus 1, right? You know, square root 3 is slightly bigger than 1, so I'm writing this before. Let's keep this minus. Now, important thing here is to rationalize, right? So rationalize means you multiply and divide by the conjugate of denominator. So we have square root 3 minus 1 over square root 3 plus 1, multiply and divide by square root 3 minus 1. Is that clear to you? Do not leave the answer at an earlier stage. You need to rationalize, okay? So now once you do that, you get minus, now square of square root 3 minus 1, right? You would expand, simplify. Denominator is a square minus b square. Correct? So it is minus. So a square minus 2ab, which is 3, minus 2ab means 2 square root 3 plus 1 in the numerator, and here we get 3 minus 1, correct? So we get 4 minus 2 square root 3. All these steps are critical, and this is 2. Now you can divide by 2, so you get minus of 2 minus square root 3. Minus of 2 square root 3 because 2 cancels. And that becomes the answer. You can now open this minus. So you get minus 2 plus square root 3. This will be negative as square root 3 is less than 2, right? So that becomes the final answer for tan 11 pi by 12. Is that clear to you? So I hope these steps are absolutely clear. Feel free to write your comments and share your views. If you like and subscribe to my videos, that'd be great. Also, you can support our channel. Thanks for your time and all the best.